In this video, I will walk you through free response question number 1 from the 1999 AP Calculus exam. This problem is about position, velocity, acceleration, and the first fundamental theorem of calculus. This problem is calculator active, so we will be using our graphing calculator as needed. A particle moves along the y-axis with velocity given by v of t equals t times sine of t squared for values of t greater than or equal to 0. Part A. In which direction, up or down, is the particle moving at time t equals 1.5? The sign of the velocity indicates the direction of the particle. Specifically, if the velocity is greater than 0, the particle is moving up. If the velocity is less than 0, the particle is moving down. Let's go ahead and put this velocity function into the calculator. Hit the y equals button. I tend to put my velocity functions on y2, I put position functions on y1, and I put acceleration functions on y3. That just helps me keep track. So I will put the velocity function here, and it was t, which we have to put x, times the sine of t squared, so that'll be the sine of x squared. And I think that was it. Yes. Now let's evaluate this velocity function at t equals 1.5 and see what it is. The easiest way to evaluate is to use the table feature. But first, I want you to change one setting. Hit second window to get to the table setup menu. Set your independent variable to ask and leave the dependent variable on auto. Now hit second graph to get to the table menu. Let me just delete what's in here. So the way I have it set up, I can type in any x value and it will give me the y value. So we want to evaluate at 1.5, so we just type that. And here it is, 1.167. All that really matters is that v at 1.5 is positive. The particle is moving up at t equals 1.5 because v at 1.5 is positive. Part B. Find the acceleration of the particle at time t equals 1.5. Is the velocity of the particle increasing at t equals 1.5? Why or why not? Second semester, we learned the graphical relationship between f, f prime, and f double prime, which determines the relationship between position, velocity, and acceleration. What's relevant to this problem is that velocity will be increasing if acceleration is positive, and velocity will be decreasing when acceleration is negative. Our strategy will be to find the acceleration at 1.5, which will equal v prime at 1.5, and see if it's positive or negative. In order to evaluate acceleration on my calculator, I need to evaluate the derivative of velocity. So hit the math button. For derivative, choose option 8. Put your x. We want the derivative of the velocity function. Remember that we put velocity on y1 under y equals. So we can access that by hitting the vars button, switching over to the vars menu, and choosing function. And there's y2, so choose that. So this is the velocity, and we are taking the derivative of velocity, which will be acceleration. And we want to evaluate at 1.5. So type in your 1.5 and kabam! Negative 2.048, or the College Board would accept negative 2.049. What matters is that the acceleration is negative at t equals 1.5. The velocity of the particle is decreasing at t equals 1.5 because the acceleration at 1.5, which equals v prime at 1.5, is negative. Notice that I'm going out of my way to mention v prime instead of just saying acceleration. That's because we are given the velocity function. We are not given the acceleration function. So all of our justifications must be in terms of velocity. That's why I'm saying v prime at 1.5 instead of just saying acceleration at 1.5. Part C. Given that y at t is the position of the particle at time t and that y at 0 equals 3, find y at 2. It looks like it's time to bust out the first fundamental theorem of calculus, which says that f at b equals f at a plus the integral from a to b of f prime. This means that the end value equals the initial value plus the net change in value. Since velocity is the derivative of the position function, we can substitute y for f and velocity for f prime. And the fundamental theorem of calculus becomes y at b equals y at a plus the integral of velocity from a to b. In this case, that becomes y at 2 equals y at 0 plus the integral of velocity from 0 to 2. But we are given that y at 0 is 3. So now we have this. We can put the entire right side of the equation into the calculator and evaluate. We can type 3 plus, now we need the integral from 0 to 2. Hit the math button, integral is option 9, and type from 0 to 2. We are integrating the velocity function, and remember we put velocity as y2. So hit the vars button, go to the vars tab, hit function, and choose y2. So this is the integral from 0 to 2 of the velocity function. Don't forget the x. And kabam! 3.827 or 3.826. Let me show you how we could do this problem by hand, just in case this shows up on a non-calculator active part of the test. We need to integrate velocity from 0 to 2, but the velocity function is t times sine of t squared. To find the antiderivative, let's do some u substitution. Let's try letting u equal t squared. In that case, u prime will equal 2t. As we make the substitution, we have t times the sine of u. Instead of dt, we will write du over u prime. U prime is 2t, so I have du divided by 2t. On the next step, these t's will cancel each other out, and I will take the 2 from the denominator and put it out in the front of the integral as a 1/2. But first, let's change the limits of integration. Right now, the 2 and the 0 are values of t, and we need to convert them into values of u. U is equal to t squared. So let's plug in 2 for t. U is equal to 2 squared, that's 4. Let's plug in 0 for t. 0 squared is 0, so this stays a 0. So on the next step we have y at 2 is equal to 3 plus the integral. Well, I'm going to take this 2 and put it in the front as a 1/2. And we have the integral from 0 to 4. The t's cancel each other out, so we just have the sine of u, du. The antiderivative of sine is negative cosine. I'm going to take that negative and put it out here in the front. So I have negative 1/2 cosine u, and I need to evaluate from 0 to 4. That means I need to do cosine of 4 minus cosine of 0. The cosine of 0 is 1. Distributing the negative 1/2, we have y at 2 is equal to 3 minus 1/2 cosine of 4 plus 1/2. 3 is the same as 6 over 2. I did that so I would have like denominators. So combining like terms, so that was kind of a lot, but that's what you would have to do if this was on a non-calculator active part of the test. Or maybe if we had a multiple choice question and we had to match the right answer. Part D, find the total distance traveled by the particle from t equals 0 to t equals 2. You know that if you want to go from position to velocity, you take the derivative. If you want to go from velocity to position, you integrate. That's why if you want to find the net distance traveled by a particle from 0 to 2, you take the integral of the velocity. However, if I want to find the total distance, I need to find the integral of the absolute value of velocity from 0 to 2. Real quick, the difference between net distance and total distance. Imagine that a particle went 5 units to the right and then 2 units to the left. The net distance would be how far the particle is away from where it started. So the net distance would be 3. On the other hand, total distance would be 7, because the total distance is the total distance traveled by the particle. It went 5 units to the right and 2 units to the left. That's a total of 7. That's why we take the absolute value, because that absolute value turns this negative 2 into a positive 2. So when we add 5 plus 2, we get 7. Instead of leaving it as a negative, if we add 5 plus negative 2, that's how we get the 3. Anyways, we can just type this into our calculator. So I want the integral of the absolute value. So go ahead and hit the math button, and the integral is option 9. And we want 0 to 2. And then we want the absolute value. So hit the math button again, switch over to the number menu, and absolute value is the first choice. And we want the absolute value of the velocity function. Remember, we put the velocity function in y2. So hit vars and go to the vars menu and hit enter for the function and pick y2. And go ahead and put your x on the end, and that's it. So the total distance is 1.173. The total distance traveled by the particle is the integral of the absolute value of velocity from 0 to 2, which equals 1.173.